Every big city has its transport problem. London is no exception. At the peak hours, overloading and congestion have grown more and more serious. But since 1962, something has been going on under London. The Victoria Line was designed to give a new fast route across the West End, to make extra links with British Rail mainline termini at Victoria, Euston, St Pancras and King's Cross, to make connections with every other underground line in London, to bring the tube to new districts, and with the southward extension under the Thames to Brixton, to relieve pressure on the buses and the Bakerloo and Northern lines. In 1962, authority was given to go ahead with construction.
Mr. Dunton, the first blocks of the new Victoria Line have been shifted. How is this first phase of the operation going to go?
Well, we are now exploring. We have to put a massive steel umbrella, a steel bridge, over the whole of this circus. And we have to found it on 24 concrete cylinders. And those cylinders must go into place without disturbing or falling upon any mains, cables, gas mains, sewers, and this place is full of them.
How long is this first phase going to take then?
Well, it depends very much on how we find the position, but I'm hoping that our bridge will be designed and out to manufacture in a few months.
A new ticket hall was needed for the extra passenger load Oxford Circus Station would have to take. The first problem was to excavate and build it, which would take several years, without holding up road traffic. Its ceiling would be only 2 feet 6 inches below the road surface. Answer: a steel umbrella bridge to carry the road traffic. To support it, 25 reinforced concrete foundation piles. They were made by drilling 3-foot diameter holes. The holes passed through a maze of underground pipes and conduits, missing some of them by as little as an inch. The holes were temporarily lined with steel pipe to retain the made ground. "25 holes, up to 50 feet deep, were drilled in 18 nights, and each was given a bell-shaped footing in the clay. Personal inspection was essential. Next, the holes were filled with concrete, having first removed the inspector. On top of these 25 concrete pillars, steel stools to support the girders of the umbrella bridge. The preliminary fitting of the stools and the marking out for drilling was of critical importance. If this survey were inaccurate, then later the whole structure would fail to fit together. There was neither time nor room for mistakes. The plan was to build the whole umbrella bridge in one long weekend, August Bank Holiday 1963. Come what might, the circus had to be open for traffic by 6:30 on the Tuesday morning. There were just 65 hours to do the job. It was raining, of course. The first girder went into position on the Saturday, less than 2 hours after starting time. The largest girder was 35 feet long and weighed just over 5 tons. In went the bolts, first time of asking, a tribute to the accuracy of the stool survey. Saturday afternoon still, and the whole centre rib nearly complete. At 7 o'clock on Saturday evening, the first deck section went into place. The night shift took over, and the deck sections continued to drop in, fitting like the parts of a construction kit. On Sunday morning at 11 o'clock, half the deck was complete, road surface and all, for the units came from the works with the asphalt already laid. The deck sections are not bolted down, which saves time, and bolts. They cannot move because the whole structure interlocks. Sunday midnight, 30 hours and 40 deck sections to go. Just after midday on the bank holiday Monday, with 18 hours left, the heavy work was complete. 245 units put into position in an average time of 11 minutes each. And right on the dot, 6:30 a.m., Tuesday, August the 6th, 1963, Oxford Circus was open again for traffic. Under the Umbrella Bridge, excavations for the new ticket hall began. They revealed the tangle of pipes, sewers, gas mains and supply cables through which the support pillars had narrowly threaded their downward way. Now, more profound operations were in progress. The digging of the tunnels. Tunnels are dug under the protection of shields. Station Tunnel, 21 feet in diameter, is dug under a modern version of Great Head's 19th century shield with erector arms inside. When the drives are long enough, the use of mechanical diggers is justified to cut the running tunnel, just over 12 feet in diameter, quickly and accurately through the clay. The rams that shove the shield forward work independently of one another, so the shield can be steered with great accuracy. The shields tow long sleds with electro-hydraulic apparatus to drive them forward and belt conveyors to shift the muck rearward. Each work site along the line of route has a vertical shaft dug to tunnel depth, 50 or 60 feet, lined with cast iron rings. Down these shafts goes everything needed: shields, lining rings, tools, men. In July 1964, this digging shield was driving from Highbury towards King's Cross. Continuous working in 8-hour shifts, 5 days a week, with the weekend for maintenance. The control in the driver's hand keeps the whole machine moving forward evenly at about 2 inches a minute, compensating for the varying hardness of the ground and making steering corrections in accordance with survey. The London clay, famous in tunnelling history since the 1890s, is the ideal medium for a new tube railway. But it isn't self-supporting for very long. Behind the digging shield, the lining must go in quickly. 1 lining ring for every 2 feet advance. Cast iron lining rings, interlocking and without bolts, and these precast concrete rings were both used on the Victoria line.
Up!
The miners, a leading miner, a second miner, and 4 miners' labourers to each shift, are experts in their trade, in demand all over the world, wherever there is a new tunnel to be dug. It takes them 7 or 8 minutes to build a complete lining ring, fitting the 11 concrete segments together and locking them into place to form a self-supporting structure which holds up the weight of the earth above the new tunnel. At best, they build 4 rings per hour, about 30 rings per shift. That's 60 feet of tunnel per 8 hours. Hydraulic jacks to expand the ring into close contact with the clay. In go the packing pieces, and the ring is there for good and all. Another 2 feet gained in the long drive. Another cutting cycle begins, another 2-foot shaft. The muck comes out fast from behind the mechanical diggers, 10.5 cubic yards for each shaft. Skip trains haul it away. 3 trains to each drive, 17 skip loads to each shaft. A belt conveyor running in an inclined shaft built for the purpose carries the muck to the surface. Where does it go? It's used to fill worked out gravel pits and so reclaim them for agriculture, to fill up quarries, even to make bricks. At the peak of tunneling, 16 mechanical digger shields were at work, each driving a mile or more before breaking through accurately into a big diameter station tunnel or an intermediate chamber. The permitted tolerance was 1.5 inches. There is no recorded instance of the tolerance being exceeded. On the Victoria line, mechanical shields dug most of the running tunnel. Short lengths of big diameter tunnel are best dug by hand. Station tunnels, for example, 21 feet 2.5 inches in diameter and only 460 feet long, are most economically dug by hand with powered clay spades, under the protection of great head-type shields. Best rate of progress here in the Oxford Circus northbound station tunnel was 52 feet per 5-day week, working 20 hours a day. Big diameter tunnel is lined with cast iron rings bolted together, and the space behind the rings is filled with a cement grouting. This is the traditional way, in contrast to the mechanically dug running tunnel, which is lined with unbolted rings and is not grouted. The miners are mostly Irish, successors to the canal diggers, the navigators, who gave their name to the railway navvies. They are like their work, big, strong, thorough, patient, enduring men. Men with great thirsts at the shift end. Among the largest tunnels was this, 35 feet in diameter, for a crossover at Page Green Common, between Seven Sisters and Tottenham. Among the smallest was this, 5 feet in diameter, for part of the ventilation system at Victoria. And there were the special tasks. At Highbury, old Northern Line running tunnel had to be enlarged for a new junction. The work must be done without interrupting normal train services. A protective hood above the existing track, which could be moved along as the work progressed. A very rare bit of brick-lined tunnel. Another special task at Finsbury Park, diverting an existing line. The old tunnel had been demolished, leaving only the track, and the new diversion tunnel had been built. Just before midnight on a Saturday in October 1965, the last service train passed over the old line. As a tremendous concession, the engineers had been granted no less than 15 hours uninterrupted possession of the line in which to carry out their complicated work. There was a gradient change involving a 5-foot difference in level to contend with. The object was to rearrange the layout so that the northbound Piccadilly platform should be alongside the northbound Victoria Line platform, and the same with the 2 southbound platforms. 15 hours to do the job. Every move had been planned in advance. Old track to be taken away, including the steel saddles and timber way beams which had been installed to support the track during the time of preparation. Awkward loads for the temporary overhead craneways built specially for this job. Every wagon load was worked out in advance, and when the first materials train was full, it was moved away through the old tunnel. The track where that train was standing can now be dismantled. This material is taken away through the new diversion tunnel. Now the new track to lay. Signal equipment to be installed. Power supply and signal cables reconnected. Everything was ready for the first train to come through the diversion tunnel as scheduled on the Sunday afternoon. Yet another special task at Euston, one of the places where the civil engineers had to contend with exceptional geological conditions. Here, the Victoria Line, forced downwards by other railways, breaks out of the London blue clay into the water-bearing Woolwich and Reading beds. The workings had to be sealed off by concrete bulkheads and airlocks. High air pressure kept back the water till the works were complete, a tunnelling technique which was later used in making the Brixton extension under the Thames. As skips come out from the high-pressure chamber through the airlock, decompression creates a sort of instant Scotch mist. The civil engineer is always contending with the vagaries of geology. At Green Park in September 1964, the unexpected took brief charge. A tunnelling shield working in the clay ran into a pocket of water-bearing gravel. No one was hurt, but the work was set back. A big excavating and pile driving operation to recover the shield was begun. Even more important, operations to find out whether the ground ahead was likely to play the same trick again. A line of test borings at 30-yard intervals, much closer together than previous borings, established the exact depth of the good, safe clay. Then, in the few places where it was necessary, chemical consolidation of the soil. 2 chemicals are injected. They combine to turn the waterlogged gravel into a solid mass. Green Park was a bad break, but civil engineers go ahead through worse events than that. They broke in through the tunnel lining, recovered the buried shield, and eventually tunneled on without further incident. Usually, the need for ground consolidation was foreseen. At Tottenham Hale Station, to make it possible to dig and line an escalator shaft, 500 cubic yards of ground were frozen solid in midsummer to a depth of 35 feet. To tunnel through the clay without causing catastrophic surface events, that's the civil engineer's perpetual problem. At King's Cross, railways interlace. Main lines from the Midlands and the East Coast. Cut and cover underground railways, the Metropolitan and the Circle. The Midland Curve, the Hotel Curve, and the widened lines. Deep tubes too, the Northern and the Piccadilly lines. So, when threading the Victoria lines in, special measures were essential. A tunnelling shield with a large number of rams to support the clay at the face. The tunnel lined, not with ordinary cast iron lining rings, but with specially designed steel linings. Result, King's Cross stands where it did. Passengers as they came and went got a glimpse of the work now and then. But mostly the builders of the Victoria line worked in a strange isolation, quite cut off from the normal world beside or above them. The Oxford Circus southbound station tunnel has to support the weight of Peter Robinson's. Under the foundations below the 3 deep basements of the store, a raft made of concrete was constructed. The raft was built in 4-foot sections in small tunnels and crossheadings. It was crisscrossed with steel tubes. High tensile steel cables threaded through the tubes were tensioned to 25 tons, anchored and grouted. Thus, the concrete raft was made strong both in compression and in tension. In November 1965, the station tunnel shield came into contact with the curved underside of the raft. The whole job had worked out to a nicety. The miners had only to skim off the very bottom of the raft, and the shield could advance and take up the weight of the building. Behind the advancing shield, they erected steel lining rings to take the weight permanently above the completed station tunnel. King's Cross again, and a moment in tunnelling history. The 20th of September, 1966, the last breakthrough. There was no celebration, it was within the limits, it was routine, but it was the last breakthrough. Now there was continuous tunnel from Victoria to Walthamstow and back. The Victoria line was designed for automatic train working. Using modified rolling stock of 1960 vintage, prototype control apparatus was installed in April 1964 on the Hainault Loop in Essex for a long period of service testing. The electronic equipment causes the train to accelerate, coast, brake to a stop, providing the greatest efficiency in the running of the trains, with fail-safe continuous monitoring of the train's performance. And the train operator, qualified and experienced, has power to override the mechanism should anything go wrong. Short service rails for the start of track laying. Jarrah wood sleepers from Australia. Surveys in the newly finished tunnels carried out with great accuracy for line and level. No room for error here. The trains are a tight fit in the tunnels. 3 surveys in all before the contractors and the railway engineers are satisfied that every sleeper over the whole distance between Walthamstow and Victoria is correctly placed to a 1/16 of an inch. Then the sleepers are concreted in. For this section, the concrete was mixed on the spot, in the big crossover tunnel at Page Green Common. The permanent rails are welded in 300-foot lengths. Northumberland Park Depot became, for the time being, a rail welding depot, fully equipped for all the processes, inspection and quality control that were necessary. The flexible long-welded rail goes from the depot into the tunnels on special trains hauled by battery locomotives. Laying it is a quick process. Now the chaired sleepers are fixed in position. For a new railway, new trains. The electrical equipment was made in Manchester, mostly to tried and true designs, with some modernising modifications. This electrical equipment then went to Birmingham, where the trains themselves were built. Altogether, over 50 contracts and subcontracts were placed with British firms for the Victoria Line rolling stock. The requirement was for 30.5 8-car trains. Each 8-car train consists of 2 half-trains, which are 4-car sets made up of 2 motor cars and 2 trailer cars. Total, 244 cars. The trains moved on their own wheels over British Rail to Ruislip Depot, where their traction motors were fitted. then, under their own power for the first time, into a testing phase. Iron passengers, patient, uncomplaining, and heavy. 2.5 hundredweight each, just 20 stone. They provide a simulated rush hour load for braking and acceleration tests at Acton. For a few days, each train became a mobile laboratory, driven both manually and under automatic control, loaded to the equivalent of 160 passengers per car, 10 tons. Braking characteristics, dry rail. Braking characteristics, wet rail. Then proved fit for service to Hainault, and soon to the Victoria Line itself. 42 new escalators were built for the Victoria Line. In the year 1911, a man with a wooden leg was employed at Earl's Court to ride up and down all day on London's first moving staircase to show how safe and easy it was. Today, it is still necessary to prove the safety of escalators, but it is done by loading them with weights to represent 1.6 passengers per step, 5 tons on 40 steps. Average stopping distance, 4 feet 2 inches from full speed. Satisfactory. Oxford Circus. The ticket hall is nearly complete, and the umbrella bridge, which had carried all the road traffic since 1962, had done its job. The civil engineers could take it to bits now, and they did so at Easter weekend 1968. They took it out so fast that their own time schedules went for waste paper. Most of the power that runs London's underground railways comes from Lots Road Power Station on the Thames at Chelsea. The installed capacity here is 180 million watts at 22,000 volts. Enough power for a sizable town. From Lots Road, the current at 22,000 volts goes to the main switch houses. The Coburg Street switch house at Euston was specially built and equipped for the Victoria Line. It is full of heavy-duty apparatus which can handle this very high voltage safely. Here, the voltage pressure is halved, transformed down to 11,000 volts. At this voltage, the current is distributed along the tunnels to the 9 substations which serve the Victoria Line with traction current at 630 volts DC. Northumberland Park Depot made the most urgent demand for power. Its substation was the first into operation. In May 1968, Northumberland Park switched on. Northumberland Park is the train depot for the whole Victoria Line. Here the trains are maintained, cleaned and stabled out of traffic hours. From here, in July 1968, the new trains began test runs into the new tunnels. over the new track using the new automatic control, stopping and starting at the ghostly unfinished new stations. On September the 1st, 1968, Stage 1, Walthamstow to Highbury, opened for traffic. On December the 1st, 1968, Stage 2, King's Cross, Euston and Warren Street became operational, and the tunnellers were going ahead on the 3.5-mile extension under the Thames to Brixton. The railway was becoming a reality, with its pianola roll train programme machines, its printed circuits, its automatic fare collection having its first full-scale tests, with its TV monitors for station control, with its trains running automatically, with its new control centre at Coburg Street, Euston, where two men, a regulator and a controller, shift by shift, ensure that the train service operates as closely as possible to the timetable, and to do so, have every modern aid at their fingertips. With train operators in direct speech communication with control.
Regulator speaking.
With completely up-to-date rolling stock, the line in March 1969 was ready for anything. And on March the 7th, 1969, Her Majesty Queen Elizabeth bought a ticket from an automatic machine which behaved just as if she were an ordinary passenger. She then officially opened the line right through from Walthamstow to Victoria. Civil, mechanical, electrical, signal and telegraph engineers, railway operators, consultants and contractors, architects and designers combined their talents and their experience. They called upon unnumbered trades, crafts, skills and specializations to put their plans into practical shape. They were backed by brawn and by brain. Thus they built the Victoria Line, the first but not the last of London's new tube railways. Walthamstow, Black Horse Road, Tottenham Hale, Seven Sisters, Finsbury Park, Highbury and Islington, King's Cross St Pancras, Euston, Warren Street, Oxford Circus, Green Park and Victoria.